Hello everyone, thanks for joining this session. Today I will be talking about CPU, GPU, and TPU. Moving on, as part of the central processing unit and graphics processing unit and tensor processing unit. So I would be going in detail about these three unit. So typically this is part of CPU, GPU, and TPU are all hardware accelerators used for competition, but by each have distinct feature and has best suits for different types of workloads. Moving on and going in detail about CPU, GPU, and TPU, I would be talking about comparing these things and, and typically covering why, what is it, how it works, and when and why it is used. And for all these hardware accelerators, as part of central processing unit, what it is, what is it? A central processing unit is a brain of computer. It is designed for general purpose computing and handles wide variety of tasks. A CPU is composed of multiple cores, usually between 2 core to 32 core in modern CPU, and each core can handle a single task or uh, instructions, single instruction or task at a time. So if you see the comparison as well, architecture perspective, general purpose, and few cores it handles. It a task type, sequential task, and control task. How exactly it works? Sequential processing in the CPU excel at a task that requires complex decision making and sequential operations. Low latency task CPUs can handle tasks that need fast response with low latency. Example, running the operating system, handle handling user inputs, and when and why it is used. General purpose computing CPUs are used for everyday tasks like browsing the internet, running application, and performing system operations. Single threaded task that requires sequential processing or have dependencies between instructions. Then control task, managing and controlling the flow of program, running operating system, managing memory and general system operations. So typically, now coming to GPU perspective, uh, what is it? A GPU were originally designed for rendering graphics and managing images on a computer, but they are now widely used in parallel processing in many fields, especially machine learning and deep learning. GPUs have thousands of small cores and often thousands of CUDA cores. Like in NVIDIA, GPUs designed for processing many simple calculation simultaneously. How exactly it works? Deep learning and machine learning in training and inference of neural networks often require massive amount of computation, and GPUs handle these tasks efficiently by processing multiple data points simultaneously. Example, training a large image classification model. Then comes rendering graphics. GPUs are still essential for graphics heavy tasks like gaming, in video rendering, and simulations. Parallel processing, um, parallel computing in tasks can be parallelized, such as large scale scenario specific computation, simulations, and cryptographics calculations. Big data processing perspective, GPUs are well suited for tasks like matrix operations, which are common in scientific computation and data analytics. Now coming to even TPU, tensor processing unit perspective, what is it? TPU are specially hardware accelerators designed specifically for deep learning by Google. They are application specific integrated circuits optimized for tensor operations, which are crucial in machine learning model, particularly in neural networks. How exactly it works? TPUs like custom hardware, where TPUs are designed to perform specific type of matrix operations and tensor computations that are common in neural network training and inference. High throughput, they provide high throughput by it for computation, especially in operations like convolutional used in convolutional neural network CNN. So basically used in CNNs and efficient scaling as well. TPUs are optimized is to work efficiently in data centers and can scale from single device to thousands of devices for large workloads. When and why it is used? Deep learning TPUs are designed to accelerate training and inference for deep learning models, especially those based on Google's TensorFlow framework. High scale machine learning models, the TPUs excel in workloads that are sequence massive parallel hill computation, such as training large neural networks. Then Google Cloud TPUs are available in Google Cloud for use of large scale machine learning in projects. So by and large, if you compare CPU, GPU, and TPUs, architecture perspective, if you see general purpose, new few cores, whereas in GPUs parallel architecture, thousands or core, thousands of cores, and TPU perspective, it is more of custom hardware optimized for machine learning task. Task type, if you see in CPU sequential task and control task, whereas GPUs parallel task, matrix or vector computational computations, and then TPUs are specially for deep learning and TensorFlow task. Now coming to speed, slower for parallel workloads. that is CPU, and GPU perspective faster than CPU for parallel workloads, and then much faster than both CPU and GPU for ML. So this is much faster than CPU and GPU. Use case perspective, the general purpose task, running operating system, and for browsing. Machine learning and graphics rendering in case of GPU, and TPU perspective, deep learning, especially learning models. Then comes what are the examples typically used in CPU is web browsing, file management, and operating system control. Then GPU perspective, training deep learning models, example CNN, and then accelerating large machine language models like Google BERT. Flexibility, a perspective most flexible for all types of tasks, then very flexible for parallel computers in GPU, and TPU very specific. It is more specific or specifically for tensor based machine learning task. Cost perspective, CPU low cost and common in most computers in day to day computers. High cost used in dedicated workstations. Then TPU perspective, high cost used in specific environment like Google or cloud. In like for example, in GPU perspective, you will heard in Oracle, so many GPUs are required for processing ML and machine language or deep learning. Then comes to summarize overall, CPU is general purpose and best for task requiring sequential processing or central processing. GPU is great for parallel processing tasks using training machine learning models, image processing, and video rendering. TPU is optimized specifically for deep learning workloads, offering extreme speed and efficiency for tensor operations. Thank you for attending this session and on CPU, GPU, and TPU. So going forward, I will be going in detail about all the various AI techniques which is being used as part of now in various application. Thank you, thanks for attending this session.